Gerlas method. I promised you I'm gonna show you Gerlas method, which is the other method to do the partial fraction stuff. Right, we use partial fractions for these kind of complicated integrals, and the idea is to factor the denominator, which we call q of x, into a product of distinct linear factors of the form ax plus b. And then we write a partial fraction decomposition using these linear factors, and doing that we had to find the unknowns a, b, and c. Right, so remember the goal was to write this as an integral of a divided by x minus 1 plus b divided by x plus 1 plus c divided by x plus 3 dx, where x minus 1, x plus 1, x plus 3 were the linear factors of q. So the problem is, how do we find a, b, and c? From the previous video we came down to this equation here. Okay, 4x squared plus 14x minus 2 is a times linear factors x plus 1, x plus 3 plus b times x minus 1, x plus 3 times plus c x minus 1 and x plus 1. For Tollo's method I refer back to the previous video, but now here I present Gerlas method, which is a good idea to present Gerla. Here's Gerla, she's a good friend of Tollo. Now this method I called being super formal, multiply everything out, finding a system of equations, and then being a math whiz to solve it. Okay, shall we do it? Let's do it. So here I multiply all the linear factors out. Okay, so then I get, for the a term, I get a times x squared plus 4x plus 3 plus b times x squared plus 2x minus 3 plus c times x squared minus 1. And now the idea is to compare the coefficients of x squared and of x and the rest. So let's group the right hand side by terms for x squared, and this is the a term from here, and the b term from there, and the c term from the last one, and x terms are 4a from here, and 2b from there, and nothing from the c term, and then all the rest. 3a minus 3b minus c. Alright, and now we compare the orders of x. So for the x squared term, for example, we need to have that 4 on the left hand side, a plus b plus c. Let's call this equation 1. Now for the x terms to be equal, we have 14 on the left hand side equals 4a plus 2b on the right hand side. And let's call this equation 2. And then the order 1 term, so which means having no x, this is minus 2 on the left hand side, and this equals all the rest, so 3a minus 3b minus c, which we call equation number 3. And so now this is what I call to be a math whiz, because now we have to solve these 3 equations for a, b, c. There are several ways to do this, but you can see if you look at it that equation 1 has a plus c and equation 3 has a minus c. So if we add those equations, the c term vanishes. So let's do that first. We add equation 1 and equation 3, and so then we get on the left hand side 4 minus 2 is 2, and then we get 4a minus 2b, and then the c term disappears. And let's call this equation number 4. Now we can simplify further by adding equation 2 and equation 4, because then we get 16 on the left hand side equals to 8a, and then the b terms cancel. We have 2b and minus 2b, so this cancels, and we do get a is equal to 2. Ta-da! And then we can take this a in equation 2, and then we get 14 equals 8 plus 2b, meaning that 6 equals 2b and b is equal to 3. Ta-da, ta-da, ta-da! Another one. And now we can use any of the equations to find c, so particularly equation 1. We use equation 1, then 4 equals 2 plus 3 plus c, and then we have minus 1 equals c, so c is minus 1. So that wasn't too hard, was it? And now we have the a, b, and c, and we can go back to our integral. The right-hand side integration is complicated, but then using partial fraction, we find these more simple terms where a is 2, b is 3, and c is equal to minus 1. And if we integrate those, we get a whole bunch of logarithms with the factors 2, 3, and minus 1 in front. So that's rather simple and has been done in the previous video as well. Let me summarize. So method 2 isn't so bad. We multiply everything out and we compare coefficients of order 1, of order x, and of order x squared, and if it happens you have x cubed and x to the 4 and x to the 5, you compare those as well. This method basically works all the time.